Okay, can everybody hear me well? Okay, good, awesome. Thank you all so much for coming to this presentation. I'm Jonathan, I'm Chief AI Scientist here at Databricks. This is my colleague Brandon, who's a Senior Research Scientist and our Head of Reinforcement Learning on the research team. And we're here today to talk to you about TAO. We released TAO 2 or 3 months ago now. It's a new fine-tuning method that we think will be really helpful to a lot of folks. And if you'd like to get access to it, it is now available in the Databricks. A lot of folks have been asking us, how do we get access to TAO? The answer is it's built into our products, and you get it right now if you just go and use the Databricks and you have data that's appropriate. So with that, we're gonna tell you a bit about this. I don't think we're gonna need the entire session, so hopefully we'll have time for some conversation. But the place to start is you want to customize an LLM. A lot of good reasons for doing this. Customization can mean anything. It can mean prompt engineering, it can mean RAG, it can mean fine-tuning, it can be pre-training your own LLM. But you want to customize one. You want a custom agent. And here's the data you're supposed to have. You're supposed to have some evals, like some benchmarks that perfectly measure your task. I see some folks in the audience who I visited with before and said, where are your evals? You have evals, right? Don't you, Vincent? And then you're supposed to have some labeled examples as well. You're supposed to have this perfect fine-tuning data, absolutely pristine. You have some example inputs for the LLM, some example outputs for the LLM that reflect exactly how you want it to behave. Ideally, you've handwritten these yourself in an artisanal manner. You have about 10,000 of them that you've been working diligently on for the past several years, and you didn't even know you were supposed to have been working on these, but you worked on them very carefully just in time for LLMs to arrive so you could fine-tune them. This is what you're supposed to have, right? The reality is nobody has this. I mean, come on, you've been preparing your data carefully for Gen AI to arrive for the past 5 years just in time to have those 10,000 examples. You have a bunch of humans on staff who can just go and do all the annotation you need. Nobody has this. This is not the reality. This is the data you're supposed to have, though. You show up and you try to use an AI customization or fine-tuning product, and you get shamed. You don't have labeled fine-tuning data, guess you can't use our fine-tuning product. You don't have an eval, guess you can't use our product. Shame on you, you should have done a better job. And that's basically what the reality's been for the past couple of years at least. For as long as I've been doing natural language processing, that's been the situation. And this is the data you actually have. This is the stuff when I've actually gone and chatted with many of you who are in the audience right now, this is what you've told me you had. You have LM inputs. Maybe you've deployed an endpoint of some kind, even if it's a prototype. You've done prompt engineering. You've used our inference tables feature, and you've collected a lot of LM inputs. Now, you have no idea how good the outputs are. The LM could be doing God knows what. But at least you have a set of inputs that reflect what your real users are trying to do, what your application is supposed to be doing. That you can vouch for. Then, what you also have is probably some relevant context and documents. You have, all the stuff you've actually been collecting over the past 5 years, 10 years, 100 years, in the case of some folks in the audience. You have those documents and context, and that says a lot about your business implicitly. Now, how to make use of that is a whole other can of worms, but you at least have some context. This is what you really have. And the third thing you have is human judgment. You have your experts or you have you, and those folks understand what the LLM should be doing. Now, if you sit them down and say, write 10,000 outputs of how your LLM is supposed to behave, they're going to quit. But you do have that human judgment, and you need to use it carefully and judiciously in the right way. That's what you actually have. And this talk is about how to make effective use of that. I'm not here to shame you, not anymore. For those of you who I've shamed before, not here to shame you anymore. I forgive you for having not predicted Gen AI 10 years ago and having prepared carefully for it. But instead, I'm here to be useful to you and tell you what you actually have and how to make use of it. And this is, I think, for those of you who saw kind of the keynote yesterday about Databricks, the whole genesis of that product was really that we spent the past year just working hands-on with various folks, including some of the folks who are here, to try to figure out how to get Gen AI to actually work for you. And from that, we've seen a bunch of patterns. We've generalized those patterns, and we've turned that into a product. And the talk today is about TAO, one particular scientific method that we developed based on patterns we saw of what data people had and didn't have. And that's really what we're here to talk to you about today. So the quick takeaway, very briefly, is TAO. It's a new fine-tuning method. It uses reinforcement learning, uses a bunch of ideas, but the goal is to make it work with the data you have. And the thing that makes it special is you don't need labeled data. It's getting the labels that seems to be the most nightmarish thing for people. And you don't need that. And how? Well, you can ask Brandon about that because this is really his work. But it's a clever combination of reinforcement learning and custom reward models that we built internally, getting test time compute and getting all the ingredients to kind of work together nicely enough in a generic enough recipe that it seemed to work on a lot of different tasks we had internally. And now we're seeing some great results for the customers who are using it. So that's what you're going to hear about today. And at this point, Brandon, it's all yours.
Awesome. Thanks, Jonathan. So Databricks is a data intelligence platform. Again, we've talked about fine-tuning, and you just heard Jonathan talk in depth about what is it actually to fine-tune your models. It's super common. A lot of other providers do offer it, but again, super common. The core issue here is in order to actually fine-tune the model, again, you need this combination of one, your LLM inputs, which again, a lot of you guys do have, but two, you need these really high-quality, clean, diverse LLM outputs. That's where you need the 10,000 labels. You have to go sit down, write them yourself, put a lot of effort into there. And again, like the running cost here is it's a very human capital intensive. Or you can also go to places like Super Annotate or Surge. But again, that does cost a lot of money to get these basically LLM outputs. So again, this is usually actually a pretty hard task and a pretty hard lift for customers when we talk to them. And so explicitly, actually, after talking to customers, we basically talked to a lot of you guys, and we found that customers actually self-select out or guide out of fine-tuning because they don't actually have enough data. Again, this core problem of having clean LLM inputs and really diverse, high-quality outputs actually have blocked a lot of customers from ever taking advantage of fine-tuning on the Databricks data intelligence platform. And to really drive this point home, basically, this is a graph from Raghavendra et al. In 2024, where you have basically 3 different data sets. And basically what we have here is a scaling law that says, hey, here's a number of samples on the x-axis, and here's the quality of an eval on the y-axis. It's IF eval. It's instruction following eval, basically. It comes from Google, and basically it measures the ability for language models to follow instructions really well. Basically, some of the examples here are, oh, hey, can you make sure you only respond in capital letters? Can you only write in rhyme tones? Can you write 3 paragraphs for this response? Basically, just very explicit instructions that are very measurable. And what this implicitly shows is that, hey, from these 3 different data sets, there is this implicit measure of data quality. Explicitly, what this shows is for the same number of samples, you'll get varying levels of quality on the eval. So if you look at just go up on the x-axis to different data qualities, you'll get different basically IF eval results. Similarly, you can actually find that with fewer samples, you're actually able to get higher quality. So for example, with let's say 100 samples from the Conifer Easy data set, it can match the quality of basically 8,000 samples from the Dolly data set. So again, overall, this slide is just to emphasize that higher quality data leads to higher quality and better results. And so this goes back to the core question here. Right now we see this blocker of, hey, the really hard part for us is we really need high quality LLM outputs. So our thought here is, what if we actually just are able to fine tune language models and customize them and make them intelligent on your data with only using the LLM inputs? So to ground this in a proper example of how traditional fine tuning works, first of all, what everyone has done is, first of all, we set up an LLM, and then they have people interact with this LLM. From here, you can use our AI gateway, and you can log all the LLM inputs from users into basically UC catalog, and basically you'll have all the LLM inputs. From here, a step would be we can either handwrite the LLM outputs you want the LLM to produce, or you could, again, go to basically a crowd-working company like Surge or a Super Annotate and have them basically write the expected outputs for these model responses. And then the last step, again, is then the fine-tuning step that a lot of people offer is basically from these input-output pairs, fine-tune the LLM to basically match the expected outputs from the responses that basically you wrote or you acquired from humans. Again, the core issue here is the LLM outputs, where it's actually very expensive in terms of if you go to one of these crowd-working companies, or very labor-intensive if you are personally handwriting these, let's say, 10,000 examples. And again, so the core blocker here is this point 3 here, where you actually have to figure out, how do I handwrite these LLM outputs? So what if there's a way to get around this? And so if we go to the TAO example that we've talked about a lot, first of all in our blog 2 to 3 months ago, and then also that we talked about now, basically, we can follow a similar step, where first we set up the LLM for people to interact with. Then we still do the same step of you collect all the inputs, again, in AI Gateway, and you can log into your UC or Delta tables. And then basically, actually, you can skip this step 3 entirely, and you don't even need to basically go through this really laborious step of finding the LLM outputs either on your own terms or by buying them from a crowdworking company. So this actually doesn't require any data annotation. And then from basically, you can skip straight to step 4 and just basically run test time adaptive optimization or TAO on Llama. But then this raises the question, like you're like, Brandon, how do I know like what should the LLM respond basically, right? I basically am saying, hey, let's skip to step 3. How do I even figure out what the LLM should say? Is this magic? Really, it's a lot of hard work from the RL team here at Databricks. So there's a lot of good science that we did. So to ground this in empirical results, I'll talk about basically the domain adaptation work that we did when we ran TAO on Llama 3.370B. What we did here is we first evaluated, this is basically all baselines, so there's no fine tuning here yet. And there's 3 benchmarks we kind of talked about here. So what we would want to do here is basically measure the performance on 3 very narrow capabilities. The first is Finance Bench, which is basically a RAG question answering LLM evaluation, and basically evaluates the abilities for LLMs to answer questions about financial basically documents. So an example of this would basically be, hey, what is Boeing's revenue in FY 2022? And you retrieve all the Oracle documents from basically the FCC filings, and you just feed it to LLM, and the LLM would answer this question. Another very narrow domain that we focus on is it's what we call the DB Enterprise Arena. This is our own hand-curated eval that we developed internally, and basically it's a well-calibrated LLM as a judge eval that basically compares the response of an LLM to a very strong LLM. It covers a lot of different domains here, so it's like open book question answering, closed book question answering, summarization, a lot of reasoning tasks here, and stuff like that basically. Just covers a pretty broad range of tasks. And then lastly, I want to talk about basically this capability called BirdBench, the eval called BirdBench. And this evaluation here, what it measures is the ability for an LLM to take natural language text and then generate an appropriate SQL query that would match basically, that can be executed, and then basically you can verify the results from the executed SQL and say, does this match basically the golden SQL that they wrote for the evaluation? And so basically what we did here is now we say, okay, let's say we actually do have these gold labels. We have enough data. We spent our time getting, let's say, 10,000 fine-tuned labels, essentially. It's not quite 10,000 for each of these bars, but let's assume we just have a training set that we can then say, for each of these very narrow domains, we fine-tune Llama 3.370B on the appropriate data for each of these domains. So for Finance Bench, we had basically financial questions, answers, and then had the golden labels. Same thing for the Databricks Enterprise Arena and for BirdBench as well. And what you can kind of see here is that we actually don't improve that much across these domains with fine-tuning. So on Finance Bench, we actually degrade performance a little bit. We tried really hard here, set our hyperparameters, did data set ablations, didn't improve that much. In a similar vein, on the DB Enterprise Arena, there wasn't that much improvement from fine-tuning. With BirdBench, we did see a slight improvement, and again, this is where fine-tuning does shine. On certain domains, you can get improvements in fine-tuning when you do have these proper, really good input-output pairs, basically. And again, that's great that we can do this. But again, it's very, very hard to curate all this data. And then let's enter TAO now. So basically, with TAO, again, all we provided to the methodology was just the input prompts. From here, we ran the overall TAO methodology, and you can actually see, we can start seeing proper gains now. On Finance Bench, we can see that with TAO, Llama 3.370B improves over the base LLM and improves beyond the GPT series of models. Similarly, in the DB Enterprise Arena, with TAO, we're able to dramatically improve the performance of Llama 3.370B to near that of basically the strong other GPT models. And lastly, again, on BirdBench, where in the previous slide, we did see that, hey, we are able to improve Llama 3.370B on text to SQL. We're actually able to further improve this with TAO. So we've already talked about basically in the last slide, what if we wanted an LLM to be very narrow, very good at one specific domain? As we get more into these agentic workflows where basically these agents have to actually cover a lot of different tasks, we want to basically have more than just this one narrow fine-tuning capability. This slide basically is saying, hey, we are now want to be much more general and much more generic. So now we're going to measure basically the performance of these LLMs across aggregate set of domains. So here it's an aggregate of basically a lot of chat benchmarks, some reasoning benchmarks, coding benchmarks, a more general benchmarks category, some math benchmarks, and some business benchmarks, basically the very enterprise relevant domains. And when you apply TAO to both Llama 3.170b and Llama 3.370b, you're able to, with TAO, improve both of these models. In particular, you're able to improve Llama 3.170b to the quality of Llama 3.370b in aggregate. And similarly, from when applying TAO to Llama 3.370b, you're able to improve it to around the midpoint of GPT-4o Mini and GPT-4o. So again, here basically we're just saying that with the ability of TAO and applying it to these benchmarks, applying it to these models, we're able to improve in this general aggregate scenario of across a wide domain of categories the performance of this LLM. So from here, we covered basically a lot of the very domain-specific stuff, or this basically academic benchmarks. We said, hey, we had a lot of these academic benchmarks that cover different categories. We're able to be very domain-specific. And then also we're able to say, hey, what if we applied TAO in a more general methodology to generically improve the LLM? The question then that everyone would want to ask is, how relevant is this to me? How well can this methodology help me on my enterprise eval? And so I want to kind of talk about basically a case study here with one of our customers, Flow Health. So Flow Health is the #1 women's health app worldwide. It's chosen by more than 420 million users. The primary use case from Flow is they want to provide health insights, find proactive ways to address health concerns, and enhance interactions with users by very quickly answering common questions with medically accurate responses without compromising privacy, and make sure you're actually relevantly answering these questions with high medical accuracy. And for them, they've definitely followed a similar journey to I'm sure a lot of you guys followed. What happened is first of all, they tried proprietary language models. This is a very common step that everyone takes, but then when they started evaluating the output quality of these models, it actually failed to meet their requirements for high medical accuracy and for strict privacy standards. And so they initially started on this path, but again, they reached this point where they say, hey, these models actually aren't good enough. From them, they then wanted to turn to fine-tuning. They said, hey, what if we had the ability to inject data intelligence into language models? And so they wanted to try fine-tuning to actually apply their own very specific domain knowledge in medical health relevancy into language models to fine-tuning. The issue for them is they again ran into a very common problem that we talked about earlier in this talk, where getting labeled medical data is actually very expensive and impractical at scale. So they ran into the same roadblock as a lot of people did here. And from there, basically, they also still had an eval that I want to talk about really quickly. This is, again, a very common journey for Flow Health and for a lot of enterprises. To measure the quality of outputs, basically, they use a number of in-house LLM judges that rate model output on several axes. For them, it was basically medical quality, relevancy, and also basically privacy-preserving judges, basically. And for them, the judges rate outputs on a score of 1 to 5. And so diving in kind of to actual concrete results of kind of their journey, you can first see this graph here, where basically we're comparing Llama 3.370b to an existing proprietary LLM. And then basically the two bars here are the percentage of scores of generations that received all 3+ from the 4 LLM judges they used, and also the percentage of scores that were 4+ from all the LLM judges they used. And then again, what you see here is for both Llama 3.370b and for the existing proprietary LLMs, the level of quality they wanted was actually just too low. It was too low for them to trust. It wasn't strong enough, and this actually caused them concern, like, what do we do with this? This is when they wanted to turn to fine-tuning. But again, for here, they did not have a set of labeled data that could actually help improve the model, because again, going back to the original point of this talk, it was too human-intensive and too capital-intensive. And so we worked with them, and actually when you apply TAO to Llama 3.370b, you're actually able to basically double the performance of Llama 3.370b to the point where it's around 60% of all generations received an aggregate score of 3 across all judges, and 54% received a score of 4+ across all judges. So with just pure labels, again, there was no data annotation required. They're actually able to apply TAO and dramatically improve the performance of the LLM on their downstream evaluation. And so stepping back here, this kind of then raises the question again of, we can now say, how does TAO work? Again, we talked about this first key step, where we want to just take all of the input labels that we have logged in our UC catalog, and then that's what everyone comes with, basically. from here, we basically apply a lot of test time compute, and we generate a lot of responses. After that, TAO applies basically DBRM, or the Databricks reward model, which we've talked about at other points during DAIS. And basically, this just enables the scoring of these responses. There's other mechanisms to score these responses, but the core one that we've used here is DBRM. Again, then from the scores, what you can do there is then from the ranked scores, you can then apply RL training to fine-tune your LLM. And then from here, that gives you your final LLM that you can then deploy and then continuously update over time, and then keep getting data, find pain points, and keep updating over time again. So the key point here is after you finish training, you're able to deploy and continually improve the LLM, and the more and more you use it, the more and more you should expect your LLM to improve. And so rewinding back to just the high-level overview of TAO in practice. Again, where everyone starts is you can just set up an LLM for people to interact with. It is totally fine for the LLM to be bad. You just want to get a distribution of responses where you see what users are doing with your LLM. Then you can again collect your inputs, so get the distribution get the distribution of inputs, and then from here you just want to run TAO on Llama. And you can again rinse and repeat, and over time, as you continue to apply TAO and continue to collect responses, you should be able to continually improve your LLM. And so now I think there's some frequently asked questions that we could go over here. So the question that a lot of people would be asking is, what are the full details? So again, there's nothing super algorithmically earth-shattering here. It's the right combination of algorithms in the right way. Basically, we spend a lot of time thinking about how much data should we generate, how do we score responses, what algorithms should we use, how do we just be very concretely scientific with what we are doing and what our end goal is. And the follow-up question then is, again, why haven't you said so many details about TAO as a whole in general? And I think the answer here is we're being very non-committal here, so we can change the details and give better quality over time. Today, again, it's this offline RL setting where basically we are saying we are just running offline RL. You do generation once, and then you just score, and you can fine-tune. Tomorrow, we can offer better online RL, better synthetic data, faster training, and again, apply more research and apply more leverage to further improve TAO over time. And then, again, more follow-up questions from a lot of customers come here is basically like, there's no way that this TAO thing works in general, right? How can that be possible? And yeah, no, that's a very fair concern, right? There's no free lunch in machine learning. This has been true across old machine learning when we weren't in the generative AI space. No, massive 70 billion parameter models. But again, as we've seen in this talk so far, across both very domain-specific and domain specialization, we're able to improve basically Llama 3.370B, these Llama models very, very well. We're able to improve it in this very general sense where we apply it to a lot of domains. And we're also able to improve it in the general enterprise case, in the case study of Flow Health. Again, the key here is really the DBRM, the Databricks reward model. The mechanism here allows us to score and rank responses and apply these RL techniques. And overall, this does apply, again, because of how DBRM is trained, it gives us a very generic mechanism that applies to a lot of different capabilities and language models. And overall here, our goal is that we want to meet you guys where you are, right? Again, with fine-tuning, it's very, very hard for customers to engage in fine-tuning because of the very core barriers of it's very human-intensive and very capital-intensive to actually get the fine-tune labels. So it's very, very, and then also again, we're meeting customers where there's a higher floor for quality. Customers do want to see basically higher quality outputs from language models, and therefore one way to do this is through TAO. And so just a quick teaser for everyone in this room. Basically, we talked a lot about DBRM in this talk, and currently the research team has been working very hard on DBRM2. So basically, DBRM2, it's actually steerable with a prompt, so you can customize it for your own use case. There's going to be a lot of different versions of DBRM2 that will basically be able to, you can constrain them, combine them, and mix them and match them. But basically, this kind of analogously would be something like LM as a judge, where you have the ability to provide your own custom guidelines and guardrails to the reward model, such that it will actually be able to say, hey, for my current enterprise use case, if I want to say, don't talk about competitors, don't say medically accurate things, whatever guideline or guardrail you want, the reward model should basically be able to respond and accurately score responses in a way that actually reflects that accurately. And so another common question we've heard from TAO basically is if DBER must be amazing if TAO beats SFT, right? This is a very common question we've seen from customers. I think the answer is yes, yes, and maybe. And so the answer is yes, DBRM is a good reward model. We spend a lot of time hand curating preference pairs and classification settings just to make sure DBRM is really strong and powerful on very common reward model benchmarks. And then yes, also TAO is very strong basically. TAO leverages a lot of the key pieces from reinforcement learning. It enables customers to only provide inputs. And it has shown very strong results so far. This also, again, because of how TAO is constructed, basically, you can actually explore many more outputs in this given space, where SFT is basically, you only have a single output that you can actually explore. And then the answer is maybe here, right? So the last answer here is TAO must be better than SFT. The answer is maybe. Again, if you had the most perfect SFT set, you had your 10,000 labels that are hand-curated to your exact domain, the answer is maybe, like SFT could be TAO. But again, that's a very high lift for a lot of customers, and we understand that. And so rewinding a bit to just, again, the broader context of things.
And this is where I come up to say the controversial things. This is where I let Brandon off the hook. I get to speak my mind and abuse my title to, say all the things that, I might get in trouble for saying. But really, the way I want to look at this is the broader context that we're thinking about as we do this. So there have been some pretty big promises about AI. You can see these quotes. I'm sure you've all seen these quotes before. These are the promises that have been made about what AI is going to do in the next year, 2 years, 3 years coming up. And I think the tricky part for someone like me, I have to face our 15,000 customers at Databricks every day. I know many of you who are in this audience personally. And I have to get in front of you and answer for all of these quotes that have been given to you by our friends and colleagues in the industry. You won't hear me say things quite like this, but I do think a lot of promises have been made, and it's time for us as a field to deliver on those promises, and I feel very personally responsible for that because I'm not someone far away just building some models and giving you an API. I know you. So we feel this acutely. We talk to customers all the time. Brandon has hung out with a lot of you as well. I've hung out with a lot of you. I've met with a lot of you this week. I have to answer to you for all of this stuff and make sure that we can fulfill at least some fraction of these promises. At Databricks, one of my favorite parts about doing research here is that at a lot of places you would have the research team talk to the product team, help to build a better product. The research team would never talk to the customers. My experience here has actually been the opposite. I go and I talk to customers. We go and we figure out something that works for you. Once it works for you, you saw that example of Flow Health. At that point, we then ship it in the product. It goes from research to customers to product, which I find to be a much better way of doing things just personally. If the researchers aren't spending time with the customers, we're not solving the right problems. And kind of the bigger theme that I've been emphasizing to a lot of you at Data and AI Summit, you kind of heard this implicitly from Ali yesterday, and you'll hear it from me explicitly today, is, I know everybody's saying 2025 is the year of agents or whatever it is, you can take that for what you will. For me, 2025 is the year of going from AI demos to real AI engineering. And I'll give you just a little bit of what I mean by that. Getting Gen AI deployed in production is really hard. A lot of you have built amazing demos over the past year. I don't know, how many of you have built a cool Gen AI demo over the past year? You've done something cool. Okay, yeah. How many of those are in production right now serving real customers? Yeah. I'd like to change that, and I think this is the year that we change that. And I've talked to a lot of you, and I've asked, what is holding you back? And the way I look at the process of AI engineering, I mean this a lot like software engineering in the sense that there's coding and there's software engineering. Those are two pretty different things. And I think the same thing is true for building a cool AI demo, doing some prompt engineering, and actually doing AI engineering. So number one is specification. This is true in coding. You build test cases, you build a design doc, that's your specification. In the AI world, it's really asking the same question, but for a different kind of system. How do I describe what I want my AI system to do? And then, of course, you have to actually verify, how do I know my system is doing this? In software, this is testing and monitoring. What does that look like in AI? And then number two is, how do I actually get a system that does this? Cool, I've got a specification, I can verify it. How the hell do I actually fix this? How do I get an AI system that meets this specification? And then how do I actually do this using what I have? These are kind of, for me, the four big questions where if I don't have a good answer to these, all those promises about PhD level AI go out the window. Let's not even start with PhD level AI, let's go with deployable AI. And so, there are a lot of answers I've heard over the past year or two. How do I describe what I want my AI system to do? Well, go build an eval. That's really hard. How many people here have an eval for their AI system? How many people here think their eval is good? Yeah, I see one hand in the back. And for that gentleman in the back, I can't wait to chat afterward. I want to hear about your eval, because find me. Let's chat. I want to know. I collect evals. That's kind of, some people collect stamps or coins. I collect evals. I also collect 3,000-word prompts. Does anybody here have a 3,000-word prompt for their AI system to try to get it to behave because they tried to do a 1,000-word prompt and it wasn't behaving properly, so they added 2,000 more words of rules? Yeah, I collect those as well. I have a board of all these things because they're fascinating. It's like a sociology of how we're trying to get AI to behave. I want us to do better. There's also, there's an easy answer, I would say, kind of honestly, this is the answer I see for a lot of products that are offered on the market. Just use AI to build your eval. First of all, building evals is really hard. And if you're giving one little prompt and saying, AI, generate me a bunch of evals, there's this information theoretic or just kind of information kind of limitation here. You've given this tiny prompt that is wildly underspecified. You're asking an AI system to inflate this into a bunch of examples that may not follow your intention. What do you think is going to happen? It's nonsense. Building evals is really hard and really painstaking. I wish I had an answer for you and the magic button you could push to make this easy. I don't. The answer is you're going to have to work hard. But we also have some products and some systems that are based on the research we've been doing to try to make this as easy as possible. OK, next part. How do I know my AI system is actually doing that? OK, just run your eval. You built a great eval, right? We have one person here who's very proud of their eval. You in the back, you're thrilled about your eval. Just run it, right? For everybody else, you don't even have an eval to run, at least not one that you're super proud of. And our answer is actually use our products. Use Databricks, use Agent Eval, use labeling sessions. And it's not to say we have magic products. What this is we as a research team have hung out with a lot of folks in this audience and a lot of folks outside of this audience over the past year. And we have painstakingly helped you manually build evals. And we found patterns, and we've turned them into a product or a family of products. And if you want, I believe it's in room 208, right? Next one's in 208. We're going to double check, but I believe we're giving a talk literally right after this session on building evals. Because now that we've gotten you excited about all the cool stuff you can do customizing an AI system, now we have to make you eat your vegetables and actually go and build some evals first. 211. OK, 211. Right after this, room 211, you're welcome to just come be my groupie for the day and hang out with me, and you can hear a bunch about evals. OK, system building. How do I get an AI system that meets the specification? Well, just get those 10,000 fine-tuning examples already, right? Just go label 10,000 examples, do some prompt engineering. The reality is this is expensive and time-consuming. And honestly, what I've seen for many of you is some of the hardest parts are the people who would give you those labels are in a completely different division of your company than you. You're on the data science team or the machine learning team, and your data labelers are on the underwriting team or the banking team or whatever it happens to be in your industry, the health team or the medical team. Good luck convincing your VP to talk to their VP to get their time and to get them to do 10,000 examples. Oh, I just need a little bit of time. I just need 3,000 hours from my underwriting team or my medical. Yeah, good luck. And then the answer lately has been use verifiable rewards and reinforcement learning. How many of you, you've seen RLVR, you've seen this work really well on math. How many of you are doing math as your task? Anybody? I've heard it's very important because I've seen it show up a lot in the leaderboards these days. Are people solving math Olympiad problems? Anybody doing that for the? Yeah, exactly. This is kind of how many people are doing coding for, their customers are doing coding? Yeah, this is the problem. We have these great models that work on two tasks with reinforcement learning, coding and math. Everybody here is working on tasks that are not strictly verifiable. They're not as clean-cut as this. So we just have to kind of hope that doing reasoning on these tasks will generalize to everything else. And we can keep our fingers crossed, or we can do science. And the last bit is how do I build it using what I have? Well, the easy answer is, well, just have better data. Gosh, your data is not good enough. Shame on you. And the answer is really this talk. We've tried to work around what people really have in practice. And the answer is really use our products because Databricks, if you go and use the Databricks product, it is the epitome of all of the lessons we have learned hanging out with customers and trying to solve problems ourselves. We've seen it work enough times when we've done it manually that we've tried to just turn it into a product flow that everybody can use. If you really run into trouble there, that's where you can call me, because we want to hang out with more customers and learn more lessons so that we can build better versions of the products. So just to give you a quick summary of this presentation, now that I've ranted at you and Brandon's given you some legit technical details, We've introduced TAO. It's a new LLM fine-tuning method developed here at Databricks. What's special? Fine-tuning without labels. It's built around the data you might actually have a chance of having, not the data that you wish you had or that I can shame you into saying you should have had. How it's a combination of test time compute and reinforcement learning and our reward model, and just a lot of really careful work to try to get the details to fit together into something that both is general enough that it'll work with a lot of different kinds of data that you might have, and specific enough that it'll actually work consistently a lot of the time. I won't promise it'll work 100% of the time. Never say that in machine learning. But it seems to work pretty well. And you can get it in Databricks today. It's now available. So with that, thank you. It looks like we have 4 minutes and 30 seconds for some questions, and then you can follow us to the next talk.